Good afternoon, students, and welcome to Q&I summer course. Good afternoon, students, and welcome to Q&I summer course. So, students, let me first introduce myself. Students, I'm Sunit Kumar, your mathematics teacher, and we have been doing real numbers from last week, and so this is our fourth lecture on real number, and today we are going to cover the proving of whether a number is whether a number is an irrational number or not. Okay, so let's start the session, students. So before starting the session, so this is the chapter which we are doing, real numbers, as we just spoke about this. And the prerequisites for today's class is you should know what irrational numbers are, which we have already covered. So what are irrational numbers? Numbers which cannot be written in the form P by Q are called irrational numbers. Okay. So now the outline for today's class is that we will prove if a number is irrational or not. We'll see how to prove it. Okay. So let's start the session, students. So we'll start the session with the first theorem. So theorem 1.2, what it states that let P be a prime number. If P divides A square, then P divides A as well, where A is a positive integer. What does this mean? Let me explain it to you. So let's say we have a prime number P. So let's say we have a prime number P and you are dividing A square by P. So if A square when divided by P, if the remainder is 0, that means this number P, the prime number P, is dividing A square. Now, if we write A square in the form A into A, and when you divide it by P, now since the same number multiplied to itself gives you A square, now if we write it separately, A into A divided by P, and since the remainder is 0, this means that A should be divisible by P, then only the remainder will become 0. Is this clear? Because prime number cannot be further, it cannot be broken down into different prime factorization. Prime number has only two factors, that is 1 and the number itself. So when you are saying that A square is divided by the prime number P, that means A will also be divisible by prime number P. And this is what this theorem states. We will use this theorem in proving whether a number is irrational or not. So, that's the next theorem where we'll prove that root 2, how to prove that root 2 is irrational. This is a very important question because it comes in exams. Is it clear, students? Have you understood this theorem?
Yes, sir. Clear.
Okay.
Yes, sir.
So you can quickly note down this theorem. So please note down this theorem so that we can move to the next part. Okay, let's go ahead, students. Now, the next theorem is prove that root 2 is irrational. So we have to prove that root 2 is irrational. Okay, so let's understand this. So let us assume, so to prove that root 2 is irrational, so we'll see it step by step because you will have to write all the steps when you are proving this in exam. So once you have understood this proving of root 2 to be an irrational number, we will do it for root 3 and root 5 as well. So that if you repeat it 2-3 times, you will understand the steps and the sequence. Okay. So Root 2, you have to prove root 2 to be irrational. Now to prove root 2 to be irrational, there are two ways of proving any mathematical theorem. One is, by straight away using different theorems to prove that. And other way is, proving it by negation. Proving it by negation means first, whatever you have to prove, you assume it to be false initially. For example, if we have to prove root 2 is irrational, let us assume that root 2 is rational. So to the contrary, let us assume that root 2 is irrational. Now, when we go step by step, at the end of this proof, if you are able to prove that root 2 is not rational, that means whatever assumption was there, which you have taken that root 2 is rational, will be false. And hence, we'll conclude that root 2 is irrational. So first, let us assume that root 2 is rational. Now, if root 2 is rational, you can write it in the form, as the ratio of integers. So we can find two integers r and s where the denominator s is not equal to 0 and root 2 is equal to r by s. So if root 2 was rational, you can write it in the form of ratio of integers r by s, where r and s are integers and s is not equal to 0. Now, in any ratio, when you have, when you have removed the common factor by cancelling the common factor between r and s, it reduces to the simplest form of rational number. So simplest form of rational number, let's say that is a by b. Suppose r and s have a common factor other than 1, then we divide by the common factor both r and s to get another rational number in simplest form, which is a by b. So let root 2 is a by b, where a and b are co-prime. What does co-prime mean? Can someone tell me? What are co-prime numbers?
Two numbers have one as a common factor.
Yeah, so two numbers which does not have any common factor other than 1 are called co-primes. Now, it is not necessary that the numbers are prime. It can be 4 and 9 as well. 4 and 9 are not prime numbers, but they are co-primes because there is no factor common between 4 and 9 other than 1. Okay. So now because you have cancelled out all the common terms from R and S, you have got A by B. Common factor has been cancelled out. You have got a simplest form of rational number A by B, where there is no factor in common between A and B other than 1. So A and B are co-primes. Okay. So now root 2 is A by B. Now if you take B, B is divided, in denominator. When you take it to the other side of the equation, it will get multiplied with root 2. So you will get B root 2 is equal to A. Is this clear, students? Till here, is it clear? Yeah.
Clear.
So let's move to the next part now. So we got B root 2 is equal to A. Now squaring on both sides. So if we square on both sides of this equation, what we are going to get is B square into 2 is equal to A square. So that is 2B square is equal to A square. So B square can be written as A square by 2. Right? When I say B square is A square by 2, now what did we discuss just now? That 2 is a prime number. Clear, students? 2 is a prime number. Now, if 2 divides A square, see, because B is an integer, A is also an integer. So if I equate integer, the other side will also be an integer. Because B square is an integer, A square by 2 will also be an integer. What does this mean? This means that A square is divisible by 2. Isn't it? If you have to prove that this is an integer, that means A square will have to be divisible by 2. Now when A square is divisible by 2, A will also be divisible by 2. Just now we had seen that theorem 1.2. where it said that if a square is divisible by p, then a will also be divisible by p. Clear? So here, since a square is divisible by 2, this means that a is also divisible by 2. Okay, so a is also divisible by 2. Now, since a is divisible by 2, that means a can be written as 2 into any other integer, because a is divisible by 2. 2 will be a factor of a. So a can be written as a is equal to 2 into c. Right? Is this clear till this step? Is it clear? Now, since you
Yes,
can
sir.
write a
Yes,
as
sir.
2 times. Okay, Ragul. So since you can write a equal to 2 times c, so what you will do, we had this 2b square is equal to a square. We will replace a by 2c here. We will get 2b square is equal to, so we had 2b square is equal to a square. Replace a by 2c. So you will get 2b square is equal to 4c square, isn't it? So you can take 2 on the other side. You will get b square is 4c square by 2. That is 2c square. So you have b square is equal to 2c square. Now, since b square is equal to 2c square, that means c square can be written as b square by 2. And because b square, c is an integer, b square by 2 will also be an integer. That is only possible when 2 is able to divide b square. That means b square is divisible by 2. So because b square is divisible by 2, b will also be divisible by 2 with the same theorem 1.2, where we say that if a square is divisible by a prime number, a will also be divisible by that prime number. So that means that 2 divides b as well. So we have two things now. A is divisible by 2. A is divisible by 2 and B is also divisible by 2. Both A is also divisible by 2 and B is also divisible by 2. Right? Now, since both are divisible by 2, that means 2 is a common factor between A and B. Is it clear? Now, since 2 is a common factor in both A and B, but what did we assume initially? That A and B are co-primes. There cannot be any common factor. So, since there is a factor 2 which is common in both A and B, since there is a factor 2 which is common in both A and B, and we had assumed that A and B are co-prime, this contradicts our assumption. That means the that assumption which we had, that root 2 is a rational number, is wrong, and root 2 is actually an irrational number. Is it clear to everyone? Have you understood the concept?
Yes, sir. Yes, sir.
Raghul, Ragvi, Jovin,
Yes, sir.
Alan,
Yes, sir.
Alan, Devi Maya, you guys have also understood? Okay, great. So I'll quickly take you to the third, portion where, we are concluding it. So therefore, A and B have at least 2 as a common factor. We have seen A is divisible by 2. B is also divisible by 2. That means A and B have a common factor 2. So, but this contradicts the fact that A and B have no common factors other than 1, because we said that A and B are co-primes. So this contradiction has arisen because of our incorrect assumption that root 2 is rational. So we conclude that root 2 is rational. So in every such question where you have to prove that square root of any prime number is irrational, you will use the same steps. So we have currently done root 2 as irrational, we will continue doing root 3 and root 5. We'll prove both root 3 and root 5 to be irrational. Now what I'll do, I'll quickly take you back to the first slide so that you can note this down. Ki how to prove root 2 to be an irrational number. So please quickly note this down, student. So this is, once you have done your first slide, I'll go to the second and then third. So you have to write all the steps which are there. Even those steps which I have, scribbled it, you will have to do that as well. So I'll quickly run through this proof once again. So we had to prove root 2 to be irrational. So to prove this, on the contrary, we assume that root 2 is rational. Now, if root 2 is rational, that means it is a ratio of two integers. So let's say those integers are r and s. So we can write root 2 equal to r by s, where r and s may have some common factor. So we have cancelled that common factor between r and s and written that in the form a by b. Now, if I have cancelled the common factor between the integers r and s, so there is no common factor remaining now when I have written it in simplest form as a by b. So root 2 is equal to a by b, where a and b are co-prime numbers. There are no factors in common. Is this clear? So now,
Yes, sir.
now I say root 2 is equal to a by b. I take b on the other side of the equation. So we get b root 2 is equal to a. B root 2 is equal to a. Have you written till here? I'll move to the next now.
Yes, sir. Completed.
Everyone? Okay. So now once you have got b root 2 is equal to a, we square on both the sides. So squaring b root 2 will give you b square into 2. Squaring a will give you a square. So we will have 2b square is equal to a square. So that means b square is equal to a square by 2. Now since b is an integer, b square will also be an integer. So that means you cannot equate the LHS and RHS of the equation has to be same. So if b square is an integer, a square by 2 is also an integer on the right side. Now if a square by 2 is an integer, that means a square is divisible by 2, then only it can be an integer. Now if a square is divisible by 2, 2 being a prime number, we saw theorem 1.2, which says that if a square is divisible by a prime number p, then a will also be divisible by p. So here, since a square is divisible by 2, a will also be divisible by 2 by using the same theorem. So since a is divisible by 2, right? We can write a as 2 times some number, because 2 is a factor here of a. So a is equal to 2 times some integer c, for example. Now I will replace in the equation 2b square is equal to a square. Let us replace a equal to 2c there. When I replace a is equal to 2c, we get 2b square is equal to 4 times c square. Cancelling, we will get b square is equal to 2c square, or we can write c square as b square by 2. Now same thing, since c square is an integer, b square by 2 will also be an integer. Now b square by 2 will be an integer only when b square is divisible by 2. Now when b square is divisible by 2, b is also divisible by 2 using the same theorem 1.2. Now since b is also divisible by 2, right, we have so b is divisible by 2 and a was also divisible by 2. Now since 2 is a common factor between a and b, we can safely say that a and b are not co-primes because 2 is a common factor. Now since a and b are not co-prime, from our assumption we had that a and b are co-primes, but eventually we are getting that there is a common factor between a and b, so it cannot be co-prime. Now this contradiction arises because of our wrong assumption that what we assumed that root 2 is rational. So that's why our assumption is wrong and we conclude that root 2 is irrational, which we have done it in this third slide. Is it clear, students? Are all the steps clear to everyone? So Raghavi, Raghul, is it clear to you guys? Alan, Devi Maya, Jovin?
Yes.
Okay. Please quickly note this down. Tehin, is it clear to you as well?
Yes, sir.
Yeah.
Yeah. So please note this down. I hope you have noted this down so that we can proceed with. Okay. Okay. Now in this next question, we have to prove that root 3 is irrational. So we'll do it one by one, step by step. Okay. So the first step was, let us assume that root 3 is rational, right? So let us assume that root 3 is rational. Now, if we have assumed root 3 to be rational, we can write root 3 as r by s, right? Where r and s belongs to z, means they are integers, and s is not equal to 0, right? Now, after cancelling the common term, so we can write root 3 as a by b after cancelling the common factor, right? Now, once you have got root 3 as a by b, I will take b on the other side. This will become b times root 3 is equal to a. So squaring, we are going to get 3b square is equal to a square, or b square can be written as a square by 3. Now, since we have b as b is an integer, b square will also be an integer. A square by 3 will have to be an integer because then only you can equate these LHS and RHS. That means a square is divisible by 3. This implies a square is divisible by 3. This means a is also divisible by 3. Right? Till this point it is clear, students?
Yes, sir.
So here you will have to state that theorem. I am just writing theorem 1.2, but you will have to state it that if if a square is divisible by a prime number p, then a will also be divisible by the prime number p. This statement you will have to write it here. Now since a is also divisible by 3, that means I can write a is equal to 3 times c. Squaring. So now what we are going to do, we will put it here in this equation, equation 1. So we will get 3b square is equal to 9c square, or b square is equal to c square by 3. So this means that c square, sorry. So here we have got that a is divisible by 3. Now this is, sorry, we have c square as b square by 3. C square is equal to b square by 3. Now this means that b square is divisible by 3, or b is also divisible by 3. So now see, a is divisible by 3. This is your second equation. B is also divisible by 3. This is your third equation. From this second and third equation, we have A and B has a common factor. A and B has a common factor which is 3, right? So now our assumption was that A and B are co-primes. But since our assumption was that A and B are co-primes, hence there is a contradiction because of our wrong assumption. Right? So because of this wrong assumption, our contradiction, there is a contradiction here, and that's why we say that root 3 is rational, irrational. So our assumption was root 3 is rational, and because that is wrong, we'll safely say that root 3 is irrational. Is it clear, students? So these are the steps which you have to write when you have to prove that root 3 is irrational. Is it clear to everyone? Has everyone understood the steps? If there is some step which you have not understood, please let me know. I'll repeat it. Raghavi, Ragul, and Ellen, Jovin, Tehin, Devi Maya. Has everyone understood it? Because this is very important. There will be a 3 marks question sure shot coming from this. Either you will have to prove root 2 to be irrational, or root 3 to be irrational, or root 5 to be irrational. If not in boards, then at least in your internal exams. And you know that internal exams also has a weightage in board exams marks. And please don't do any shortcut. You will have to write these steps. Please don't jump. Few students don't take this R by S. They directly start with A by B, right? But it is always advisable that, do the steps which are given in your NCERT book. Don't skip the steps, because every step, carries some marks. Okay, students, let's go ahead. So now there are 2 more concepts which you should understand, which you have already done in your previous grades, is that the sum or difference of a rational and an irrational number is irrational, and the product and quotient of a non-zero rational and irrational number is irrational. Means if you have a sum or difference of rational and an irrational number. So for example, if you have something 2 by 3 plus of root 2. Now this is a rational number, this is an irrational number, right? So if you have rational plus irrational, in fact plus minus anything can be possible, sum or difference, is always an irrational number. Is it clear? What does this second thing says? The product and quotient of a non-zero rational and irrational number is irrational. Means if we have something 2 into root 3, so this is rational into irrational. So rational into irrational, this will always be irrational. Or if you have root 3 by 5, so this is irrational divided by rational. So this again is an irrational number. So product and quotient of rational and irrational, or sum or and difference of rational and irrational, will always be irrational. Is it clear? Students, is it clear? You have understood this?
Yes, sir.
Okay. So let's go to the next question. Quickly write this down. So, it is always better that you make your own notes from all these lectures which we are delivering right now. Because if you write your notes, if you maintain your notes, you can always revise it when the school reopens or when you have an exam. You will only have to flip through some of the pages which you have made as note. Otherwise, you will have to go through the whole book and different books. Okay. I hope you have noted this down. Let's move to the next slide now. Now we have to show that 5 minus root 3 is irrational. Now, as I said in the previous slide, we saw that, this is a rational number and this is an irrational number. So you will start with, now here we don't have to prove that root 3 is irrational because we have already proved that, and we have seen that square root of any prime number is always irrational. Now we have done it for two examples. We have done it for root 2 and root 3, and we'll do it for root 5 in a while. So that 5 minus root 3 is irrational. Now since root 3 is irrational, so since root 3 is irrational, we will have and 5 is rational. What we saw just now was rational minus irrational is irrational, right? So you will not do it, directly. You will again prove it by contradiction. We know that this is going to be irrational, but this is not the way you have to prove. Since you have to show it, we will do it in a different way by negation. Okay. By contradiction method, which we have just done. So when you have to prove it irrational, you will assume it to be rational. So let us assume that 5 minus root 3 is rational. So if 5 minus root 3 is rational, you can safely say that 5 minus root 3 is equal to a by b, where a and b are integers and b is not equal to 0. Now what you will do, you will bring all the numbers on one side and you will isolate that square root term on one side, so that that irrational number is taken to one side. So what you are going to do is 5 minus a by b will become root 3. I have taken minus root 3 on the RHS and we have brought a by b to the LHS. So if you take LCM here, students, you will get 5b minus a over b is equal to root 3. Now since a and b are integers, right? So this whole thing is what? Integer divided by an integer, which is a rational number. And root 3 is what? Irrational. So you can never equate a rational number to an irrational number, right? So you will write, since LHS is rational and RHS is irrational, we cannot equate a rational number. So we cannot equate a rational number to an irrational number, right? So there is a contradiction here because of our wrong assumption, right? You have rational number in LHS and irrational number on RHS. You cannot equate them together. You cannot equate a rational number to an irrational number. Your left hand side and right hand side in an equation has to be same. It cannot be two different kind of numbers. So that means this has happened because of our wrong assumption. So what was our assumption? Our assumption was that 5 minus root 3 is rational. This implies 5 minus root 3 is irrational. There are only two possibilities, right? It will be either rational or irrational because we are studying only real numbers right now. So if 5 minus root 3 is not rational, that means it is irrational. So that this is how you prove that 5 minus root 3 is irrational. Are the steps clear, student? Have you understood the concept?
Yes, sir. Clear.
Okay. So please quickly note this down and then we can move to the next. Students, what are the chapters which you have done in school?
Sir, we have finished first 3 chapters, sir.
You have done
First 3
first three
chapters completed.
Okay, so we'll also target to complete first 3 chapters in your during your summer vacation, and if it is possible, we'll go ahead and do the fourth one also, so that you get a heads up. You are ahead of the syllabus when the school reopens, and you have already covered up what has been done in school, and you have revised it properly and practiced it properly. Okay, so that's why platform practice is very important. So when we are doing the concepts here in the class, we are revising the concept. You have to go back on the platform and practice as many questions as possible. Okay, so that you understand your level of understanding in a particular topic, your proficiency in a particular topic. Okay, you have noted this down. Let's move to the next question. Now here you have to show that 3 root 2 is irrational. Now again here, what you are going to do, let us assume. So let us assume that 3 root 2 is rational. So that means 3 root 2 can be written as a by b. So here, if I have to isolate root 2, I will take 3 on the other side. I can write it as a by 3b. Now since a by 3b, a is an integer, 3b is an integer, a by 3b is rational and root 3 is irrational. Right? Now we cannot equate an irrational number to a rational number. So this contradiction occurs because of our wrong assumption. Right? What is our wrong assumption? That 3 root 2, this implies 3 root 2 is irrational and not rational. Right? The assumption was that 3 root 2 is rational, but that led to an equation where LHS is irrational and RHS is rational. So there is a contradiction here. You cannot equate a rational with an irrational number. Now that contradiction occurs because we have had a wrong assumption that 3 root 2 is rational. So that means 3 root 2 has to be irrational. Is it clear?
Yes, sir. Clear, sir.
Okay. So students, what I'll do is I'll quickly take you to the platform and give you today's homework. So how many of you practiced on the platform? How many students practiced on the platform and did the homework which I gave you yesterday? Ragul, only Ragul. What about others? Why could others not do? How many students have their login ID and password? Those who have taken the proficiency diagnostic test, how many of you have already taken the test? So those students who have not got their login IDs and password, they'll get it latest by today so that you can attempt the proficiency diagnostics test on Friday, 11:30 a.m. So you will have your proficiency diagnostic test at 11:30 a.m. On Friday. This is for those students who have not taken the test till now. Those who have already taken the test, you can start your practice. So I'll give you a homework today again from the platform. So students, when you log in, you will see this dashboard. Now on the assessment section, click on practice and custom practice. So in mathematics, let's say we have covered real numbers, you will see the topics here. And in view topics, I had given you HCF and LCM already, right? Now, you can do this explain properties of irrational numbers. The first topic which you see on the left, explain properties of irrational numbers. So this topic you can practice, students. So students who have not received the login ID and password, we are going to, call you today, connect with you today. Take your registered email ID and mobile numbers. We'll create your login IDs. You can take the first proficiency diagnostic test on Friday, 11:30 a.m. And from there, your learning journey will start on the platform. Okay. So, which is a big differentiator basically. So practicing on platform will help you understand whether you have understood that topic completely or not. So your current understanding or current proficiency of a chapter or topic you will get to know only when you practice on the platform, right? And so that you are sure and confident that you are completed with that chapter and you can move to the next chapter. So before the end of your summer vacation, you should target to complete all these 3 chapters, practice it completely, complete all the questions there and have a proficiency of more than 95%. Okay. So thank you, students. Thanks for joining in. Study well, practice on the platform, and we'll meet again tomorrow and continue this chapter. Okay. So we'll try and finish this chapter tomorrow. Okay. So thank you. Thanks for joining in. Bye and take care. Have a very nice day.